Okay guys, in this video we're going to look at solving another quadratic equation, except for in this instance, instead of taking a graphical approach, which we'll still do here just to check our work, we're going to take an algebraic approach. And so specifically with this type of equation that you see here, we can solve it using square roots. And so what we're looking for is any equation that can be written as u squared equals a number d. So solving with square roots, first things first, it can be written in the form u squared equals d, where d is just some number, but u is any expression. And so simply put, what we're looking at is a situation where as long as we have something being squared and only one thing being squared, then what we could do is we could get that thing by itself and take the square root of both sides. So when I mention that u is any expression, what I want you to keep in mind is that with this equation over here, what if I were to say let u equal the expression x minus 1? Well, then in reality, this would be the same as the equation that you're going to see me write right here. This would be 4u squared plus 2 equals 10. And you could see that very easily we could just get this thing by itself by subtracting the 2 and dividing by 4, but then just turning around and taking a square root to solve this. And so what we're going to do is not rewrite this with a u in the place of x minus 1, but recognize that because we only have one thing being squared here, namely the x minus 1 factor, what we're going to do is we're going to get this factor by itself, the factor being squared, and then we're going to take the square root of both sides. So to get this by itself, remember that we always want to undo addition and subtraction before we undo division and multiplication. So I'm going to subtract 2 from both sides of this equation and rewrite everything. So I get 4 squared term here equals 8. And so now at this point we say, well, can I take the square root of both sides? Well, we want to hold off on that until we get the thing being squared, which is this x minus 1 by itself. So to get rid of this 4 in front, while it's multiplying by 4, we're going to have to divide by 4. And so division by 4 here works out nicely on the right side. As a matter of fact, we get just 2. So long story short, now that we have this thing that's being squared by itself, what we could do is we could take the square root of both sides. Now, one thing to keep in mind is that when you take the square root of something that is squared, it just undoes the squared, since squaring and square rooting are inverse operations. The other thing to keep in mind is that when we solve this, whenever you take the square root of something, we're always required to put a plus or minus out in front. And now the reason why we do this is because we could either have squared a positive square root of 2 to get 2, or squared a negative square root of 2 to get 2, because anything squared always comes out to be a positive anyways. So once we get to this point here, all we need to do is now look over on the left side here is to get this x by itself. So the way we're going to accomplish this is just to add 1 to both sides. Now doing this, one thing I will mention is that I always want to put this constant in the front of or to the left of the plus or minus, just as a matter of writing this. But we say 1 plus or minus the square root of 2. Now I'm going to put a box around this and point out a few things here. The first one is this. This is actually 2 answers. And so if we want to list both answers, we're going to list them separately. We have to write them as, well, one of them is 1 minus the square root of 2, and then the other one is actually 1 plus the square root of 2. So what I'm going to do is I'm actually going to go back to the original equation here, and let's say I do set this equal to 0 and I do take a graphical approach. I'd have to subtract the 10 over to the left, but what we get is this equation that would have been written like this: 4 times the quantity x minus 1 squared minus 8 equals 0. And the reason why I mention this is because when I go graph this thing, okay, my vertex would be right 1 and down 8. So right 1, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you don't have to graph this. I'm just doing this to go to show. But we would say, okay, so here's my axis of symmetry at x equals 1. And then with my a value here, I'd go right 1 and up 4. Now, if this is the point 1 comma negative 8, then to go right 1 and up 4 would put me at 2 comma negative 4 and 0 comma negative 4 here at these 2 points. So we'd say 2 negative 4, and then we would say 0 comma negative 4. So this graph, what it does, let me fix that. It's going to drive me crazy. Oh, that's going to drive me even crazier. This is just a mess, guys. Negative 4. We get this thing that looks like this here, and that wasn't very good. Let's try this again. Like this. So now remember what we're looking for graphically are our x-intercepts. And I know that I didn't draw this beautifully, but what I can go do is actually show you by on a calculator, what we would get is decimal values here. So 1 minus the square root of 2, if I take 2 and I take its square root, and I'm going to say, okay, let's do this. 1 minus this here. So if I store this in my memory plus 1 minus memory recall, I get negative 0.41-ish. So this is approximately 0.41, and it's negative. Over here, if I do 1 plus the square root of 2, this will be a little bit easier to do. We'll say take the square root of 2, the square root of 2, and then we'll add 1 to it. We get about 2.41. So we get about 2.41 on the right side, and on the left side we get negative 0.41. But you can see how these would cross at x equals negative 0.41. So x equals negative 0.41. And then we would also have crossed to the right of 2. We'd say this is x equals 2.48-ish. So just keep this in mind. When you're solving equations using square roots, what we're looking at is a situation where we can get the squared thing by itself and then take the square root of both sides and simplify if necessary. Cheers.